Now, factorization method of solving a quadratic equation. Let's look at it carefully. Let me start with a very simple question. If I give you solve x square equal to 25. See, the degree is 2, so this also falls under the category of quadratic equation only. Now, this is very easy to understand because from here we can directly say it is x equal to 5 or minus 5, because we know that 25 is 5 square, so it is either 5 or minus 5. Right? So here we already know. So how do we apply factorization here? Let's look at this. Bring this 25 to the left hand side. It becomes, so we already got the answer of this. I'm just trying to show how to use factorization in an easier situation. Here we have x square minus 25, that is equal to 0. Now this can be written as x square minus 5 square, that is equal to 0. We have learned the formula a square minus b square is equal to a minus b into a plus b. Let's apply it here. What happens? It will become x square minus 5 square will be x minus 5 into x plus 5, that is equal to 0. Now you see, this is a product of two things. Now when the product of two things is equal to 0, that means any one of them has to be 0. So this tells us either x minus 5 is equal to 0 or x plus 5 equal to 0. From x minus 5 equal to 0, you can see that x is equal to 5. And for x plus 5 equal to 0, you can see that x is equal to minus 5. Right? So these are the two solutions of the given equation. Okay. Now, here it was very easy to factorize, right? Because it was simply a square minus b square format. What if this is not in this format? Then how do we go about it? So now I'll share with you the perfect method of factorization of a quadratic expression or quadratic equation. Let's see. Suppose we have solved x square minus 5x plus 6 equal to 0. Right? Now, when we say in the general form ax square plus bx plus c equal to 0, here this a, b and c, these are the constant terms. This a is the number that is being multiplied to x square. So it is a is called coefficient of x square. This b is called coefficient of, coefficient of x square. This is coefficient of x. This c is the constant term. Right? Now, knowing this, what we can do here is look at the coefficient of x square. Now here it is 1 into x square. Coefficient of x is 5 and the constant term is 6. Right? What the method says is take the coefficient of x square and the constant term, that is a and c, and then multiply them. Right? Get a new value. So in this case it is 1 into 6. We get a value as 6. Right? Now break this product 6 as a product of two numbers. Right? In all possibilities. So one possibility is already this one, that is 1 into 6. There is another possibility, 2 into 3. Right? So it is either 1 into 6 or 2 into 3. Okay. Now go back to this and look at the sign of the constant term. Here the sign of constant term is positive. The sign of constant term, if it is positive, then what you should do is go to each possibility and add the numbers. So if this is plus sign, add the numbers. So if you add, you will get 1 plus 6 as 7, 2 plus 3 as 5. Please look at this carefully. If the constant term has positive sign, then you need to add these things. Right? Similarly, if it was a minus sign, then you need to take difference of these two things. Okay? Now in this case, it is plus sign. So take the sum of these two, you will get 7. Take the sum of these two, you will get 5. If any one of these numbers is present as a coefficient of the middle term, I repeat very clearly, if any one of these numbers, that whatever sum we have calculated, any one of these numbers, if it is a middle number, if it is the coefficient of x, then only the factorization can happen. Right? Now here, 5 is here, so the factorization is possible. How will it be possible? Let me write it again. It is x square minus 5x plus 6 equal to 0. How did we get this 5? This 5 is 2 plus 3. Right? So what we do here is we say x square minus. In place of 5, we take 2 plus 3 into x plus 6 equal to 0. Be extremely careful about the bracket and the sign. In place of 5, I am writing simply 2 plus 3. Okay. Now, this is, if you open it, it will be x square minus 2x minus 3x plus 6 equal to 0. Now, from x square and 2x, you can take x common. Inside it will be, from x square, if you take out x, x will remain. From minus 2x, take x out, so you get minus 2. Now, from these two, take minus 3 common. So, from minus 3x, if you take out minus 3, x will remain. And from plus 6, if you take out minus 3, see, 6 is equal to minus 3 into minus 2, right? So, if you take out minus 3, it will be minus 2 again. Then, if you see, from these two expressions, x minus 2 is common. Now, if x minus 2 is common, then if you take this out, x will remain from here. If you take this out, minus 3 will remain from here. So, it is x minus 3 equal to 0, right? Now, this whole process looks a little longer. Your agenda should be to reduce the length of this process. This work can be done mentally. Whatever I have done here, this thing can be done mentally. Okay, if you are able to do that, then the time taken will be much lesser. Okay, now I'm writing this expression here again. So now we have two 1 degree terms. See, the whole purpose of factorization is to get all terms in 1 degree. So that individually, because the product is 0, individually we can equate them to 0. And we can get our required values of x. So from the first one, x is equal to 2, and the second one, x equal to 3. So the solutions are x equal to 2 and 3 for this particular equation. Alright, so just go through the method again. I'll repeat. Multiply the first term, multiply the coefficient of the first term, multiply the coefficient of x square with the constant term. You get a value. Then break it into product of two numbers in as many possibilities as are there. Okay. Then, if this is a plus sign, if the constant term has plus sign, add in each possibility. If the outcome, if one of the outcome is present as the coefficient of x, it can be factorized, right? That means if there is no value here which is present here, then no factorization is possible, right? We'll look at those cases later on. As of now, just understand that if there is no outcome here, no factorization possible. Similarly, if this was a minus sign, we would have taken difference. In place of sum, we would have taken difference. Let's take another example of this. Now, I am keeping this here, and now let's take up this question. It says 2x square minus 3x minus 9 equal to 0. Alright. So let's take coefficient of x square, that is 2, and the constant term, that is 9. So 2 into 9 is equal to 18. Break 18 into product of two numbers in whatever possibilities are there. So it is 1 into 18, 2 into 9, 3 into 6. That's it. These are the only three possibilities. Now look at the sign of this constant term. Now this constant term has a negative sign, right? Negative sign. Now this minus sign means take difference in each case, right? So the difference is, in first case, in 1 and 18, the difference is 17. 9 and 2, the difference is 7. 3 and 6, the difference is 3. Then check whether the middle coefficient, the coefficient of x, is any one of these numbers. 17 is not there, 7 is not there, 3 is there, right? 3 is there, so this can be factorized. Now please understand, if none of these number was present here, we could not have factorized this equation. Okay. Now, how did we get this 3? This 3 is actually 6 minus 3. Right. So what we do here is, we say, let me remove this. I repeat, now that we know this 3 can be written as 6 minus 3. It has to be written as 6 minus 3. We'll write it as 2x square minus. Please be careful about the sign and the bracket. This 3 has to be written as 6 minus 3, right? And then you open the bracket. Please understand, x is as it is there, minus is as it is there. This 3 has to be written as 6 minus 3, that's it, right? So we get 2x square. Now open the bracket, it will be minus 6x minus plus 3x minus 9 equal to 0. From these two, you can take out 2x common, you will get x minus 3. And from these two, you can take 3 common, you will get x minus 3 again. It is equal to 0. I hope you can see, from 2x square, if you take 2 out, x out, 1x will remain. From 6x, you take 2 out, 3 will remain, x is already out. From 3x minus 9, 3 out, so x will remain, and from 9, 3, that will be remaining there. Now, if you take out x minus 3 from these two things, so x minus 3 out, and we will have from here 2x, and from here plus 3, that is equal to 0. So it is either x minus 3 equal to 0 or 2x plus 3 equal to 0. Okay, so we have x equal to 3 or minus 3 by 2. Alright, so now let's take a couple of more examples on the basis of factorization.